6.3, this is the last note and assignment questions sort of in this one assignment package, and it's looking at what we call other rates of change. Okay, so we're looking for ROC, which is rate of change, for different relationships besides speed. Okay, and it can mean different things. So we said, I said speed equals rise over run. Well, really rate of change equals rise over run, and that's important to know. Okay? And actually that's what I wanted to write right there. It is always found using rise over run. Okay? So we want to calculate the rate of change in this first example. And, here we're given a little graph, some data. And this is centimeters of snow. Okay, so my unit here is centimeters. I'll just write that down now. And my unit here is hours. So units for rate of change follow the same pattern as speed as well, because speed is a rate of change. It's just it's a particular example. So we want to find our rise, we want to find our run. So the run, it starts at, let's see, it goes up by 1, 2, 3, 4. Okay, so run is 4 hours. And the rise, it's starting right here. Right? Let's see how this graph works. It goes 0, 2, 4, 6, 8, 10. So this point is 10. So it starts here at 2. So these are sort of hard to read because they don't give you the numbers exactly, but 2, and it goes up to 10. So the rise is 10. Okay? So you just see how far it goes up. Starting at 2, ending at 10. That was bad, really, really bad math. Maybe you found my mistake there. Rise is not 10. Rise is 8. It's how much it changes, right? So it starts at 2, ends up 10, so it goes up by 8. So rate of change is rise over run, so it's going to be 8 divided by 4, which is 2. And let's just get these units straight, okay? It's the unit on here, which is centimeters. It's the Y unit divided by, over, or per, the X unit, hours. Let's put H for hours. Okay? So what does that mean? What does it represent in this case? It represents the amount of snowfall per hour. We're getting 2 centimeters every hour. That's the rate of change in that graph. Okay? Next, just another example. This is an interesting one. This one is someone's reading a book, maybe Ferd's reading a book, and it's pages remaining. That's horrible. Horrible, can't read it very well. I hope yours is better. The y-axis then really is pages, right? If we're going to give it a unit, it's just pages. And I filled in some of the stuff here because you can see that where the, that would be 20, that would be 40. Make sure you read that, okay? 60. 80. So it's going up by every box represents 10. 10, 20, 30, 40, 50, 60, 70, 80. So this ends at 90, right? So, and my, kind of goes from here to here. So my run is the full 6, in this case, days, right? So because it goes from, all the way from 0 to 6. So run is 6. And my rise, again, it starts at 90, so this is going to be negative. It's a negative slope, okay? So it's starting at 90, ends at 0, so the rise is negative 90. It drops by 90. Okay, so the rate of change equals rise over run. Equals negative 90 over 6. Oops. 6. Equals negative, don't use a calculator, 90 goes into 30, or 6 goes into 35 times, so it's 15. Negative 15. And the unit is pages per day. Okay? So that, in this case, and what does it mean? It represents the number of pages read per day. That's all. So really, Ferd or whoever is reading 15 pages of his book every single day. And so the pages remaining is dropping, right? So if it was a 100-page, or I guess it was a 90-page book, right? Then every day there's 15 fewer pages to read. Okay, right into the assignment. So you can see the first question, right? Determine the rate of change. This page here got written down with a pen, obviously. But determine the rate of change, and what does the rate of change represent? Exact same question, okay? And you're going to go ahead on your assignment. This is a little experiment. I'm going to show you how to do this. So this should be set up in the back of the room, and I'm going to get you going on it. You can work by yourself or with a partner, whatever you like, on that little experiment. And you're going to collect your own data for rate of change. Okay, so I'm going to help you with all that. So you'll see the vertical spring is set up, and you're going to add different masses to the spring. So you're going to list what the masses are, and that's going to be your X value. And you're going to measure the length, which is going to be your Y value. And then what you'll do with that data is graph it and determine the rate of change. And then that's going to be it. That's the end of this assignment. And you'll shortly get a whole new assignment to work on.